Great, you have added it successfully. So it says 200, okay. And where we are running it all? We are running it all in the Docker container. So this is the beauty of Docker Compose. Hey guys, welcome to Code Decode. Today in this video, we will be looking into how to Dockerize your Spring Boot application, how to connect it with a database container and manage both containers with a single file and command. That will be done through Docker Compose. So we will start with installing Docker. We will see why Docker Desktop and not Docker Engine or simple Docker. What is the bare minimum requirement for you to install Docker on Windows or Linux machine? How to Dockerize your Spring Boot application? How to Dockerize your MySql database container? And how to make them interact with each other on the same network? What is networking? What is bridge networking? And what is the default network given by Docker to us? So let's get started. Please like, share, subscribe and comment so that this video reaches to more of the people who are preparing for interviews like you. We'll first start with installing the Docker. To install Docker, you have this docker.com, the products for Docker Desktop, and install the Docker Desktop from here. Now you will ask me, you want Docker, so why are you installing Docker Desktop? You can also start with installing the Docker or Docker Engine, which will internally also will help you to Dockerize or containerize your application. But in Docker Desktop, you get loads and loads of preferences. The Docker Engine is just a part of Docker Desktop that you will get when you install the Docker Desktop. So Docker Engine is something you get with Docker Desktop. Then it also has a GUI interface for you to see how your images are created, how volumes are created, how containers are created. I'll show you how Docker Desktop looks like. I have actually already installed Docker in my system. When you follow all these steps, what I'll tell you in few minutes, then even your Docker Desktop will look like this, which is a proper GUI. You don't have to work only with the CLI or command prompt, writing the commands and waiting for the results to be seen in the form of black and white screen. Rather, you can see all your images, all your containers here. These are the containers, these are the images, these are the volumes. Everything that you need will be shown as a GUI, and this is the Docker Desktop for you. But also there is some scenario where you would like to go with a Docker Engine installation and not Docker Desktop. And that scenario is when you have your company with 250 plus employees having more than 10 millions of annual revenue. In that scenario, your Docker Desktop will be licensed one and you have to pay for the subscription. It only remains free for the smaller companies, the private use, the open source projects and educational purpose. For the enterprise applications and big large companies, you need to purchase license for Docker Desktop. So in such scenarios, these Docker Desktop license will not apply to Docker or Docker Engine. In that case, you can happily go ahead and use Docker Engine, but only thing you will get is CLI. You will not be able to see all this GUI and everything, but everything you can do is with the command prompt. Now, since I'm going to use it for the private use only, I'm going to use a Docker Desktop as of now. What are the steps to do that? You can go here, install it for this. You can also have options for Apple chip, Intel chip and Linux. These are for Mac, this is for Linux and this is for Windows. Whatever your operating system is, there is a bare minimum requirement which is also we will be covering in the few seconds to see whether you will be able to run Docker Desktop in your system or not. After that, you can start downloading it. Once the download is complete, you can run the installer and follow the prompts. Now it will ask you for multiple things. You can follow the prompts and install Docker Desktop in your system. But there is one catch in Windows. Whenever you install the Docker Desktop in Windows, it will need you to enable the hypervisor or Hyper-V for virtualization on the operating system or Linux. So it will install the Windows subsystem for Linux during installation, which will help you create a Docker Engine layer over your operating system. So this is your hardware, this is your operating system. Over this a Docker Engine layer will be created, and on Docker Engine your multiple containers will run. To create this environment, you will be needing the hypervisor to be enabled for Windows. Now once you are done, you can go here and check on the desktop the Docker version. Now since I have already installed it, will successfully run on my system. It says Docker version is 20.10.23 and all these, this is for the client and this is for the server. Remember, Docker is always in the client and server architecture, where through the client you give the command, the server will have the daemon and everything. So this client and server architecture and the internal architecture of Docker, we will be seeing when we will be covering the theory part of it. But remember all these points, these will be asked in interviews whenever you go for the trickier part of the Docker interviews. So the Docker always comes with the client and server configurations. And this is how you check with the Docker version command what is the latest version you have in your system. Once done, you have Docker Desktop installed successfully. you can run and create your Docker containers. Now once done, you will also see in the start menu the Docker desktop for you. So clicking that will actually take you here, and here you will be able to manage everything. Now we will see why we have used Docker desktop and not Docker engine. I'll show that to you, because the first thing that you get is Docker engine, which is the internal part of it. You get Docker CLI. So I have showed you that even with CLI, I'm able to run the commands and still get all the features of Docker engine that you would have got if Docker engine would have standalonely installed in your system. So Docker desktop also gives you the CLI. There is Docker Compose, Docker Swarm, we will be seeing in the later part of this video. There is also a support for Docker Hub. I'll show that also to you. There is also support for internal Kubernetes. There is a support for GUI based interaction with your containers, images, volumes. There is also have a capability to have the resource management, your CPU, memory and everything. Go to the settings. In the settings you have resources. You have options to handle all your image locations, networking, proxies, WSL integrations. So all your resource handling can be done in your settings of this Docker desktop. Also you have option for volume management. You can see here these are volumes. You can delete the volume. You can do multiple stuff with these volumes. Also the Docker desktop will give you the IDE integration. Suppose if you are using the Visual Studio Code or IntelliJ, it will give you a plugin setting with Docker desktop here also, like this. So Docker desktop provides you the complete developing environment for building, running, testing your Docker applications. We will be doing everything in this video today. Now remember one very important thing. You will not be able to run your Docker desktop if you do not fulfill the bare minimum requirement, which I have listed down here. If you're using Windows, then the bare minimum requirement for OS is the Windows 10. For the lower versions like Windows 7, 8, you will not be able to run the Docker desktop at all. The reason being the Hyper-V or the layer that is needed for virtualization will not be available, and hence you will not be able to install the Docker desktop in your system. So make sure only if you have Windows 10 or higher, then go for Docker desktop in Windows. Similarly with macOS, go for 10.14 and even newer than that for the newer models of Mac. Otherwise you will not be able to run the Docker desktop on your Mac machine. Also you should have at least 4 GB of RAM. You should have Hyper-V and WSL2 feature. It is not available prior to Windows 10. These two features are bare minimum requirement for Docker desktop to run and create a layer of Docker engine and containers over your operating system. This will not be possible if there is no Hyper-V and WSL2 layer enabled. And these features are available only after Windows 10. Also remember, whenever you install the Docker desktop in Windows 10, it will give you a prompt. Do you want to enable the hypervisor and WSL2 configurations? You have to tick it as yes, or do it in BIOS, go in BIOS and do it. If this is not enabled, you will not be able to use the Docker desktop. Now let's get started and Dockerize a Spring Boot application. So to Dockerize a Spring Boot application, you need two things: Docker and Spring Boot application. So let's go and download a Spring Boot template from Spring Initializer. I'm going to use a Maven Java 2.7 version. I'm not going to 3 as of now. I'm using the lower versions with 2 only. I'm going to name it as com.codedecode.docker. The name will be the Docker. The demo project for Spring Boot Dockerization, and package name will be again com.codedecode.docker. I'm going to package it as jar as of now, and I'm going to use Java 17. Let's add dependency of web, Spring Web, and then generate. Now you have docker.zip created. I have it installed in my system and I have downloaded it here in the code decode projects with the name of Docker, and the SRC is ready for me. Now I'm going to open this in IntelliJ. I have imported this Docker project in my IntelliJ. It's downloading the dependencies, if you can see, and once it is done, you can see that we have the Spring Web dependency here. We can try running whether this is up and running or not. So it has started. So our test application that we have created with Spring Initializer is perfectly fine. Now what we need to do is Dockerize it. Create a package called as controller, and in the controller I'll create a class Docker demo controller. In this controller, what I'm going to do is I'm going to create only one method that is going to return a hard-coded string value which will say yes, my application is up and running on Docker. So I'm not going to put much of the CRUD operation as of now, because we will be doing it as soon as we integrate with the SQL container when we create the SQL container in Docker. I'm just going to mark it as REST controller with the request mapping of /docker and a get mapping of test API which says I am running fine. A simple, nothing decorated as of now. And we will Dockerize this application and build the image and run the container and see whether we are able to interact with this container. We will see if our application is running perfectly fine in local. Then create an image for it, create a container out of it, run the container and test we are able to connect with the container or not. So this is running fine. Let's try this with the Postman. API will be created as localhost 8080 Docker test API. This will be http://localhost/docker/test API. And see, we are able to run it perfectly fine. We got 200 okay, I'm working fine. I'm working fine is something which we have returned from here. Now the task is to Dockerize this application, create an image and run it as a container and see whether we are able to connect here or not. So the first thing you need to do is to create a Dockerfile. So here, just create a new file, name as Dockerfile. Now the Dockerfile that we are going to create here is already explained in the first video when we have started learning what Docker is all about. There I have explained each and every step which is going to go into the Docker file. So I'm going to just copy paste it and just for a quick revision I'll explain it also. So this is how I've created my Docker file. This is the base image. This image is taken from the Docker Hub. I've shown that in the first video how this image is present in the Docker Hub. Now your working directory will be /opt where all our jars will be created and that will be the working directory in the container which we will be creating in few minutes. Now we are exposing a port 8080 and we are creating an environment variable port. We are going to copy everything that is in target folder. So in target folder, whenever you do maven install, you will have a jar file created. That jar file will be copied and only .jar file will be copied and saved in the container. But at what location? Because you have opted for a working directory /opt, the jar will be created at that location inside opt and name will be app.jar. And the last point is entry point execute and your script. So what does this script say is java -jar your app name .jar. So what the java -jar will do, it will run your jar and hence will run your Spring Boot application. You can see the logs when I will be running the container and then we can hit the container and see whether application is running fine on container or not. So this is the entry point which will be executed as soon as a container starts. So that was all about the Dockerfile, a quick revision of what I have already shown you in the theory part in the first video. Now before we build an image that we can see in the Docker desktop, first I need to cover the Docker Hub also. Login at Docker, I'm going to log in with the code decode and this is hub.docker.com. This is also I have covered in the first video when we were covering the theory for Docker. Now you can see this is our login code decode 25. All the images can be seen here now. You can always push your image here. But now remember, always your namespace should be the starting point of your image creation. So whenever you build your image, always remember to initialize with your account namespace. And then you will be able to see your image also when you push it. So now I will be building my image. But before that, I need to go to the location where the image has to be created from because it needs the location where Docker file will be present. So Docker, in the first video also I've shown you, the Docker file is given as an input to the Docker build command and then the Docker image will be created. So Docker file is necessary to build a Docker image. Now here we have the Docker file. This is the exact place where I need to have my CMD running and here I'm going to build my image. The Docker file says copy from target to the container. But to copy from target should have the .jar present, right? And how do we create a .jar here? By maven install command. So here in the Docker lifecycle, let me install it. When you install and when the installation is successful, you can see a .jar created here. So I can see build is success and I can see that in the target I have my docker.jar created. Now since now the Docker jar is created, you will also say there is one more docker.jar.original. But what I have given here in the Docker file, the command is to copy anything in target which has an extension of anything.jar only, not anything.jar.star. So anything.jar is only this. This is .jar.original which does not match with this regex. Hence this will be ignored and only docker.jar will be copied from the target folder to your opt of app.jar. I will show that also when our container is created. I will get into the container and will show you how this app.jar is created in the opt folder of your container. So now let's quickly build an image with docker build. -t is for tagging your image. Now before tagging your image or giving the name to your image, remember you will have to push it to your Docker Hub, right? 3 things will be there. The first thing is -t, that is to tag your image. The namespace, that is in Docker Hub. The name of your image and the version, that will be the tag of it. And also remember to put a dot here, that is going to specify the root folder. That's where the image is going to be created, in the root folder. So let's quickly go there, build an image with name as namespace as code decode 25 / your image name. So I'm going to give a Docker demo image and I'm going to create it in April month. So I'm going to put it as month also just for tracking. So Docker demo April and the version 0.0.1. That is the first version of this particular Dockerized application. And also remember one very important thing, to create it where. So I'm going to create it in the root or the source folder. And when I do enter, you can see that it is loading the build definition from the Dockerfile. So that is why I said we need to be at the location where the Dockerfile is present. Do not try to create the image where the Dockerfile is not accessible to Docker. So Dockerfile is exactly present at this location. This is the Dockerfile which is present at code decode Docker folder. And this is code decode Docker folder where we have built the image. That image is actually getting created using the Dockerfile. The base image is taken as OpenJDK 17 Alpine that we have given in the Dockerfile again here. Working directory is taken as OPT. We are going to copy everything in the target folder to this app.jar in the OPT folder. And you can see here, this is the base image created with SHA. So when your image will be created, in the Docker Hub, you will be able to see this SHA B6B4 and the Docker image will be named as code decode 25 Docker demo April 0.0.1. So if you can see here in the images, you have Docker demo April 0.0.1. Where is 0.0.1? It's in the tag. So that's why I said that is the importance of namespace, your image name and your tag. And if you can see here, I'm going to copy it to clipboard. I'm going to paste the SHA here. You can see this SHA is exactly same as B6B488E. B6B488E. This is exactly same SHA that is being created while writing the image. So while it is creating an image, this SHA is created and you can see the same SHA here. So this says that your image is successfully created now. Now you have your Spring Boot project. To Dockerize it using the Dockerfile. Using the Dockerfile, you create an image. With that image, when you run that image, the running instance of image becomes the container. To make this image as a runnable instance, you need a container, and container is currently not created here. So we need a command to create a container. To run the Docker container, you need a Docker run command. But Docker run command should have a name of the image that you are running, but it also have -p and a port forwarding. -p is a firewall rule. Why is it used? Because your image will be created as a container. Now container will be running. Now you want to expose the container's internal port so that you can access it from your Windows machine. This is your Windows machine and I want to access the container from my Windows machine. So you need to forward your port. So port forwarding of your Windows machine's port from your container port. So you are running your jar on container. A container is having it running at 8080, but I want to access it from 8080 of my Windows. If you don't do this -p 8080:8080, you will not be able to run your container from local. That is a host machine. So you need to expose container's port through the specified host port, and thus it binds the host 8080, that is your Windows application 8080, to container's internal 8080. If you miss it, you will not be able to run your Docker container from your local. So I'm going to run this now. Docker run port forwarded to 8080 of my host machine from 8080 of my container's machine. And the image that I want to run is this. So I'm going to copy from here and paste it here. So I'm going to run my code decode Docker demo April 0.0.1 image. Oh, it says it is not allowed. Why? Because I think you must be running it somewhere. So since this is already running, 8080 is not available in your local. Now since I have closed that 8080, you can see all the logs are now coming to your command prompt. So it says, okay, now Docker is running, you're creating your container. The container is getting created. It is created and it is running at 8080 on your local machine. And it has started it. So this is how you see your logs here. And let's see the container, whether we are able to create the container or not. Okay, so can you see we have a container created with a weird name, right? And if you can see here, it is up and running. The name is very weird because you have not given any name to your container and hence it is created like this. You should also put a name in this command. If you want it to be a specific name like vaccination center, demo container, we'll do that also. But let's see first whether, since this is up and running, it's in running state, let's see whether we are able to hit it from local port 8080. I'm duplicating this, my test API, but rather using localhost 8080. Now containers IP will be host.docker.internal 8080 and the rest API remains the same. And see, we get 200. Okay, I'm working fine. So remember, when you are doing testing in local, you have localhost 8080. But when you are running through a port forwarding, a Docker container, you should not use localhost because you have switched it off. You can remember I have stopped my Docker application at localhost. Now I'm running it at internal Docker host 8080. So you can see you are using the host.docker.internal host name and not the local host because you are connecting to your Docker host from inside a Docker container. It's not your local host anymore. It's the container, Docker container that you have created and you are trying to connect to your Docker container. So obviously this will not remain the local host. It will rather becomes host.docker.internal. Now since this is working fine, we are capable enough to create a container and hit it from local. Now as discussed, I don't want to have any such kind of name. I'm going to delete such names from here right now. So before this, I need to stop the container first. I'm deleting the container and I'm going to delete my image. I just want to give it a proper name to the container. So I'll create an image again using docker build space -t, your namespace, your Docker image and the version and the root source folder. If you try to do this and thought of giving it a camel casing with D capital and A capital, it will not allow you. It will say that invalid argument, the repository must be in lowercase. So what you have done wrong is you have created a Docker demo in a camel casing thinking, okay, let's follow the best practice. But Docker doesn't work in that way. You have to keep everything in small cases while creating an image. So your A must be small and your D must also be in smaller case. Now when you create this image will be created perfectly fine. As you can see here in the images, your Docker demo of April is again created. Now your container is not available. To create a container, again you need Docker run -p for port forwarding from container 8080 port, then your image name. And the important part to do here is after port forwarding, give minus name and your container name should be Docker demo April. So I have given that port forward from 8080 container internal to localhost 8080 to your host 8080 in your Windows and give the name as Docker demo April to the container. Let's see if it runs. You will be able to see the logs here. If you do not want to see the logs here, you can also use -d here. So you may add -d flag before -p, that is port forwarding from container to your host machine. If you use the -d flag, you will be not seeing the logs and the logs will be running in the background for this container. But as of now, I want the logs to see whether my application is running perfectly fine and on which port it is running. So I've not used the -d as this. But remember to use -- name, which is required to give the name to the container here like this, Docker demo April. So here also you can see the logs. Now the container is up and running. I want to open the terminal. And we are already in the working directory /opt. Why we are already in opt? Because we have given the working directory in the container as /opt. Now if I do ls, you can see that a base image is created using the Dockerfile here and in the /opt app.jar is to be created, which is running. So app.jar which is created and it is running. This is somewhere we are inside a container. So this is the container. This is the name of the container we have given through the command line while creating the container, and this in the terminal is here at opt. All these things in the container comes from the image itself. And from where in the image it comes from the Dockerfile itself. So you can say that while Dockerizing your Spring Boot application, the main file is always the Dockerfile. It gives the command to how to create an image, and hence it gives the command how to create a container. Now this was all about how to containerize a standalone Spring Boot application. So this was a standalone Spring Boot application having one controller interacting with nobody. It's just a simple get API which says okay, I'm running fine. But real world is not that easy, right? You need to connect with the database, add the data to the database, get the data from the database, and it's not that simple, right? So now you have not just one application, that is Spring Boot application, you also have a MySql container. And to connect to the MySql container, you will also need to have a connection to the MySql image like you have here. In the Dockerfile, when you wanted to create a Java project, you have taken OpenJDK help, the base images that you have taken. To create a database of MySql, you will need an image from MySql, obviously from where you get these images, the base images, you get it from the Docker Hub or the repository. Now I want to enhance this application and connect with database. The first thing that you need to do to create a connection to database is to go to the pom.xml and add all the dependencies that is needed to connect to a database. So let's go here and add the dependencies for data.jpa and a MySql connector, which will help you connect to the database. If you do not have MySql connector, you will not be able to connect to the MySql database at all. So I have added my Spring Data.jpa and SQL connector in this application. I'll remove the jars as of now because I'll need to run it, maybe install again to have the latest data dependencies into it. The next thing that you need to do is to create a properties file. I'm going to create a new file, name as application.yaml, which will be used for connection to database. This is something we have already covered in the previous videos where we have seen how to connect with the MySql database when we were seeing the CRUD operation with Spring Boot. So I'm not going to repeat everything, just for your reference. You need these two dependencies to connect to the MySQL database and some properties to be able to connect to DB. If you would have running it in local, you would have used localhost 3306. This is a local default MySQL port. You will be using a URL that using the JDBC connect to MySQL database using localhost 3306, which is a default port. This will be the DB name, connect automatically. The username and password you will be giving here. You will be giving the driver name and the dialect and the Hibernate DDL auto to update. Now these are the bare minimum properties that you need an application to connect to DB. This we have already covered. Now what you need is to create an entity which will become a table in this database. Then you need a service layer, a repository layer. We have seen all these things to be covered in the Spring CRUD in local. The same thing you have to do when you are Dockerizing it also. So I'm going to create an entity, a package called as entity, a package called as service, and a package called as repository. Entity will have a new class. As of now, we'll say demo entity. So I've created a demo entity here with ID, name and address. And I'm creating a demo repository also here, which is having a demo entity which is going to be saved into the table. Now I have my entity ready. I have my repository ready. Ideally, I should have a service layer which will be interacting with the repository, interacting with the entity. But as of now, since we are just giving a demo, I can directly go into the controller and auto wire the repository. Do not do that. This is not a recommended practice. Always auto wire a service here, then auto wire a repository into the service. But since I'm just giving a demo, I'm going to auto wire the repository directly. I'm going to create two mappings, get mapping and post mapping. Get mapping to get all the employees saved in the database, and post mapping to add the data in the database. So one post and one extra get method here. So this is the post mapping to add an entity into the database, where I'm going to just directly save it in the demo repository. And one get all method, which is going to find all the entities present in the database and return it in the response entities list of demo entities to us. Now I have my controller ready. I have everything ready. I need to connect this application to a MySQL database. So just this Docker file will not be enough. I also need a connection to database. So I need a Docker Compose file. What we have seen about Docker Compose is that Docker Compose is the one which is helping us to attach multiple containers in one service. So in this service, I will have one Spring Boot application connecting to one database. So these two together becomes one Spring Boot Docker demo service doing. So I need a Docker Compose file where I'll be having two containers. One container will have Spring Boot application and one container will have MySql DB. So here we have Dockerfile. I'm going to create one more file. Name as docker-compose.yaml, and here I'm going to paste some line of codes. Now it says the Docker Compose file says version 3.8. I'm going to have services, and services is going to have two things: my application, which is created from an image, and the image will be Docker demo April. So I am going to create an application using an image. The port forwarding has to be done when you run the container. Port forwarding from 8080 to 8080 has to be done. And in the environment, use the database. Remember, I have not used localhost here. Why? Because I do not want this container of Spring Boot application to be connecting to the localhost. I want this to be connected to my container that I'm going to create as a part of this Docker Compose file. So this Docker Compose file is the one responsible for creating two containers. One container for Spring Boot application, one container for MySql database, and then they both will be interacting with each other using this data source URL. I have given some data source URL already in application.yaml, but this will be ignored if you have Docker Compose. So Docker Compose will be the priority, application.yaml will be the second priority. So if you're giving a database source URL here, this will be ignored. This was something I was using to test the local. But this is something that I'm going to create to connect to the container of MySql DB, which is deployed in Docker as a container. So I'm going to create two containers, application and database. Currently, if you can see, I have only one container named as Docker demo April. Now I'll have container like this having multiple applications. This is just an example of microservice. Don't get confused. I'll create that also for you. Consider here, this is only one single container having not the multiple containers, but when you use Docker Compose, you will have a container name having multiple containers here like this. So this is the beauty of using Docker Compose. You will create multiple containers using one single file. Dockerfile is capable enough to create one. Docker Compose is capable enough to create multiple images and containers for you. So first an image will be created with this. Here, for the database, the image will be taken from MySql 8.0.27. Can you think about what can this image be and from where will it come? This is again the base image, and this base image will come from Docker Hub or Docker repository. Similarly, it is going to use an image which is not a base image. This image is going to come from Dockerfile. So we are creating an image from here. So this image is going to come from there. It is getting port forwarded using a JDBC connection to a container which is created here. The database source name should always be admin and root, or whatever you want to keep it, but most of the time if you use root and root, it will not allow you. You have to use it as one of the user as admin. And it also says depends upon DB. So what is DB? If you can see, this DB is nothing but this DB. So this is the DB container which is getting created from the base image of MySql. The host is Docker MySql. The default port is 3306. Again, the password is root, and the MySql database is something that you are also using here. This local Spring Boot DB is same as local Spring Boot DB here. The username will be admin and the password will be root. So this is same as admin and root here. So this is how you configure your Docker Compose YAML to have two applications connecting with each other on the same network. I'll show how these both are connected to the same network when I'll run the container. So first we need an image, and since the image is going to change now, I'm going to remove all the images and containers as of now by stopping it. I'm going to delete everything. These were the standalone containers. I don't need it anymore. I'm going to delete everything and start from scratch for you. I'm going to clear the screen. I'm going to run maven install so that the jar will be created here. Now if you can see, our build is success. And since build is success, you are able to see your docker snapshot.jar. Now you are capable enough to run your image, create your image and create your containers. So let's go again back to our project and build an image similar to what we have created before. Currently you can see there is no container and there is no image. So let's again create an image, docker build, tag your image, docker demo for April, and a version of 0.0.1. Add the root. Don't forget to put this dot at the end, that is for the root source folder. It's building an image. Now you just need to do Docker compose. Now since you are using Docker compose, you are not going to run the Docker container, rather you are going to run a Docker compose command. So Docker compose up. I can see my image is created, but no container is created. So let's see if container creates with this. Okay, great. So I can see that a Docker, the name of the application that we have given, right? So Docker is created. Let me show you the logs here now. The log says network Docker default created. Now I'm going to come back to this. Remember, this is very important. This is the name of the application, that is Docker for us. And underscore default is the default bridge that is created, network bridge that is created by Docker compose for you. And two containers are created, a DB and an app. It says started the application. With the Docker compose, what you have done? You have created two containers, app and DB. Can you see app and DB here? So yes, app is here, DB is here. If you can give the MySql int is done, everything is running fine for us. So your two containers are created. Only one image is created, Docker demo, which is also having package for MySql, which is a connector to your database, and your container is up and running with two containers inside it. So these two containers being on the same network can interact with each other. We have created CRUD. Let's see if CRUD is working fine. So we have a controller with all and add. Let's try all first and see if we are able to get all the demo entities. It says empty because we have not added anything and it is working fine. Now let's duplicate it and put a post request. Add demo entity. To add a demo entity, we have a post mapping. So I'm going to change it to post with a add as the URL. So at the Docker internal 8080, I'm going to add an employee. This is an ID which is necessary and two more parameters. So let's create a JSON with an ID integer and string of names, center name and center address. So let's create a body of raw JSON, center and address as Bangalore, say Whitefield. Suppose just a dummy data. Now let's try to run it and see whether we are capable enough to add your employee through this controller. And says great, you have added it successfully. So it says 200, okay. And where we are running it all? We are running it all in the Docker container. So you can see get all employees. Now you will not get empty. Now you will get something out of it. So yes, you are getting something out of it. This is something that you've already added just now. So this is the beauty of Docker Compose, where you are capable enough to connect your multiple applications, be it a Spring Boot application connected with a MySql DB. You are capable enough to create two containers simultaneously with just one YAML file. That is Docker Compose for you. We will be seeing all the parts of Docker Compose. We'll also use this Docker Compose when we will be using the microservice implementation. You will have multiple applications working simultaneously and they need to interact with each other. If they are on different networks, they will not be able to do that because Docker is by default meant to be very secured and safe. To make it more safe and secured, what they have done is they have created some networks. There are types of networks. We will all cover all the types of networks in the theory and interview questions part. As of now, understand that since we need Docker to be safe, it is working with the networks. I can show that to you using a command docker network ls. If you can see, there is a bridge. This is a default bridge network that is being created. These are all the networks created by the Docker internally for you. There is also Docker underscore default. If you can see, what is this Docker underscore default? I asked you to remember here. This Docker underscore default is created. So this Docker underscore default network is created when you are creating two containers simultaneously with Docker Compose, that is the Spring Boot application connected to the MySql DB. This MySql DB, you can see we have not configured anything in the going into the container. We have not created any jar, no Dockerfile, nothing. From where this DB is created? This DB is created using the base image from the Docker Hub. How is this connected with your Spring Boot application? This is connected using a network internally. And on that network, there are two containers connected, a database and your Spring Boot application. And why these two containers are created on the same network? That is because of the Docker Compose file. You have given that in a Docker Compose file, I need in the same service application and DB to be connected together so that they can interact with each other, because I need to save the data from this application, because controller is in my Spring Boot application and data has to be stored in my database. To connect them and get the data, retrieve the data, you need them to be connected with each other. To have them connected with each other, we have Docker Compose. So again, in Docker, a bridge network allows containers to connect to the same bridge network to able to communicate with each other, so that other containers outside the network will not be able to connect and provide you the security. Now, bridge driver is automatically created for you by default. When you start a Docker, a default bridge called network called bridge, you can see it here. This bridge is created this default by Docker to you, and the newly started container connect to it unless specified. Also, you can create your own custom bridges. Now, when you create a compose file, you end up creating a single network for your application. So when we use the compose file, we end up creating a single bridge network, and the name is the name of the application underscore default. So when I was creating the application, if you remember, I have named the application as Docker. So application name underscore default is the default network created for your Docker Compose. Now each container, currently we have two containers, a database and a Spring Boot container, connects to this default network, and both are reachable by other networks on the network. So this is why your MySql is able to connect to Spring Boot application, and Spring Boot application is able to save and get the data from your MySql DB. So it is created with your project name underscore default and two containers. So that was all about Docker and Docker Compose, and how to do CRUD operation in a Spring Boot application, and how to connect with a MySql DB, which is not on your local but on the container side. So here you can see you have a database in the container side. You can see you have all the logs here. So this is MySql which is created here, a database getting initialized. So all your data is here. Now I'll prove you that in this database, which is created from this base image, we'll be able to interact with this, and the data that we have stored, that is one code, decode and Bangalore Whitefield, will be stored in this DB only. So for this, I need to connect to the container first. You can see in my local, there is no SQL yoke, there is no SQL local connection, right? So first I need to get into this container, and getting into this container, I need to show the databases and show table for you for that. So from the command prompt, I have this command docker execute the container ID bash. So with this, I am able to get inside the container, and the container ID will be this. So this is my container ID. With this, I'm going to get inside the DB container. Now I'm inside the root. Now I need another command, that is MySql -u, your username and password. So MySql space -u. My user ID is what? I can see that in my Docker Compose file. My user ID is admin and password is root. So my user ID will be admin space -p. Now it is asking for password, which is root. It says welcome to MySql monitor, and since we have used this docker execute command, we are into the container. This container is nothing but a database container that we have created here, this DB container. So now I am inside this container. Now I want to show you that yes, I have created a database and I have created tables into it. So what should be the database name? The database name should be local Spring Boot DB. The name is confusing, I agree. So I'm going to say show databases. It says this database is created. Now since there were two databases, I need to select one database for which I need to show all the tables. So I'm going to use my local Spring Boot DB. Now it is going to read table information and column names from this local DB, local Spring Boot DB, and the database is changed. So now if I do show tables, it will not give me error, and it shows you have created a demo underscore entity. How is it created? Because you have created an entity here, demo entity, and hence it is created as demo underscore entity in DB. Now if I say select star from demo underscore entity, it can show that it is with ID 1, code decode and Bangalore Whitefield. Isn't this the same data that you have entered here? So this is how I have proved you that we are inside this MySql container by giving a container ID here and executing that and getting into it, and the bash is opened for this particular DB. Then you have entered into the MySql DB by giving the username and password. Then you have given the database name, then you have shown you all the tables, and then you have done the select star from the table to show all the data that you have entered here. Now if I try to add one more data, another row should be entered here. So if I go here and add one more data, say 2, and I'll say new center for code decode, again in Bangalore Whitefield only. Let's see, it says it's 200 okay, and also it is able to get it here. Then it says it has 2 things to be shown here. Now if I say select star, you can see there are 2 rows added on the same address, that is code decode center and new center for code decode. So this is the new that you have added, new center for code decode, and you can see here new center for code decode is added, and hence I have proved you that now you have nothing local connected. Everything that is connected here is on the Docker only. So this is how, when you push this image onto the Docker Hub, you will be able to pull this image anywhere on any kind of server, be it production, be it dev, be it test, and just run this container, and you will be able to get the data and store the data exactly how we are doing it here in this server. So that was all about Docker implementation of Spring Boot application and interacting with the multiple containers in a single file as a Docker Compose. I have multiple more things to cover in Docker, the Docker architecture, microservices for Docker, many things are to be covered. If you need a trickier questions on the interview perspective on Docker, just let me know in the comment section. I'll continue this playlist, else I'll stop this and I'll start another new playlist for some another topic for Java. That's all from the Docker side, implementation. I'll be waiting for your comments. Thank you for staying so late with me. I'll see you in the next video. Bye-bye.